Hey everyone, hi. Hope you guys can see me and hear me. I'll just try and go on live via the YouTube app to confirm. Hi Manohar, good to see you here. Just adjust the camera a bit. Good morning Manohar, good to see you here. So the agenda for today is that we will be discussing how to work in different bases. That's the idea, that's the guideline. Now, for those of you who do not know, who might be attending my classes for the first time, let me tell you, my name is Ravi Handa. I've been teaching for CAT for close to 15 years now, and I've taught 20,000 plus students online via my own website, handafunda.com. And recently, I started taking classes on Unacademy as well. If you want to know what class am I taking where, what my schedule is like, and all of that, I would recommend that you join our Telegram group, which is shown over here. That is at t.me or Telegram link at Cat Prep Online. You should be able to find it over here. As a part of this, I'm actually taking classes on YouTube and via special classes, and there are the paid courses. Now, as far as YouTube is concerned, I'm taking classes in the morning, that is at 10 and 12, which deal with number system, and in the evening at 5 and 7, classes which deal with time, speed, and distance. So that's broadly what my schedule has been like. As a part of special classes, I am conducting, 3 of them, I believe, tomorrow on Saturday. The important one is the one at 7 p.m. In that 7 p.m. class, I'm going to primarily discuss a business awareness quiz. I would request you guys to attend that. And as a part of the paid courses, I'm actually conducting a course on logical reasoning this particular month. These are some of our top performers from previous years. If you work hard, you can go ahead and join them. Some of the batches which are starting, there is a batch on the 2nd, on the 5th, and on the 9th. As I am a part of the batch which starts on the 9th. I'm a part of the batch which starts on the 9th. And as a part of this particular batch is when I will be doing LR. So if I'll be focusing on LR, there is Ronak as well, Harpreet ma'am as well, will be focusing on quant and other stuff. And you can go ahead and join this particular batch. You can use the coupon code HANDA. To get a 10% discount. Same. And if you opt in for a 6-month subscription, you will get one additional month extra with it. That means your course is going to be valid till the exact exam. Every Sunday, there is a scholarship test which is conducted. And, to unlock that test, you might be asked for a referral code. Once again, you can use the referral code HANDA. And the top performers in that, they get it, the entire course subscription for 1 year for free. So it has those benefits. There are batches which are starting for IPMAT and BBA exams as well. Now, these are exams which are given by students who are in class 12th. Unacademy also has an Ask a Doubt feature where you can click a picture of a doubt, send it to us, and I or someone from our team will clarify that. Now, before we get started with base system, if there is anything else that you want me to address, please let me know via chat. On the other hand, if you want me to start taking the class and start with base systems, please type OK so that I know you guys are ready. I very strongly recommend have a pen and paper for this particular class because there will be calculations which will be involved where you will need a pen and paper for this. So please have that handy. Shashank says he's good to go. Now, the normal base system that we operate in, is defined by a series of 10 digits. that is defined by a series of 10 digits. What are those 10 digits? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the set of digits which is given to us. This is the set of digits which is given to us. And as a part of this, when we have to move to the next number after 9, we move to 2 digits. And the same idea can actually be used to figure out how to move across digits and how to move across various other calculations and stuff. Let me see if I have a blank slide somewhere where I can show these conversions to you. Yes, I have a blank slide here. Let me try and show you and explain these conversions a little bit. So suppose you are operating in base 3. Now in base 10, when you want to write down your numbers, you will write down 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then 10, 11. This is how you will write down your numbers in base 10. Very similarly, you will do the same thing in base 3. But what happens in base 3 is you only have the digits 0, 1 and 2. You don't have 3, 4, 5, 6, 7, 8 and 9. So you will write 0, 1 and 2. What will you do after this? How are you going to figure out the next value? Once you have run out of the digits that you are available to express, what are you going to do? How are you going to figure out the next value? What you are going to do is, what did you do here after 9? You moved from 1 digits to 2 digits. You moved from 1 digit to 2 digits. So this will be 10, then 11, then 12. What will you do after 12? You don't have 13. So suppose you had gone till 19 here. What will you do after 19? You will do 20. So 20, 21, 22. What will you do after 22? So you did 0, 1, 2, then 10, 11, 12, then 20, 21, 22. Then what will you do? Can you tell me that? What will be the next value? See, basically, when you move till 99 in your decimal system, when you have exhausted everything that you can do with 2 digits, which is the biggest 2-digit number you can form in base 3? It is 22. You cannot form anything beyond 22. So what will you do? You will move on to 3 digits. So 100, 101, 102. And this is how your list is going to proceed. So now the point here to note is, as long as we are working in base 3 and comparing it with base 10, what is with a single digit? How many numbers can you represent in base 3? And how many numbers can you represent in base 10? Let's try and figure this out. So with a single digit, double digit, triple digit, and n digits. And suppose let's also try and do that when the base is, suppose, B. Now, in your decimal system, that's the easiest. With single digit, you can represent 10 numbers. Double digit, you can represent 100. triple digits you can represent 1000, and n digits you can represent 10 to the power n numbers. What are those numbers? 0 to 9. With double digits you can go up to 99. With triple digit you can go from 0 to 999. With 10 to the power n you can go from 0 to 10 to the power n minus 1. Are you okay with these values for 0 and for 10? Let's try and understand the same logic what you will be able to do in case of the base as 3. In case the base as 3, with a single digit you went from 0 to 2. So you had 3 numbers 0 to 2. With double digit you went till 8, which is 9 numbers. Do you see a pattern here? Do you see a pattern here with what was happening with 10, with what is happening with 3? Do you see a pattern here? Do you see a pattern here? Yes, it is powers of 3. So with triple digits, you can go up to 27, which is 0 to 26. And with n digits, you can go till 3 to the power n. That will be 0 to 3 to the power n minus 1. Just the power of the base. In this case, it will be b from 0 to b minus 1. B square numbers 0 to b square minus 1. B cube numbers 0 to b cube minus 1. And b to the power n, which will be 0 to b to the power n minus 1. This is the set of numbers which can be represented. Are you okay with these values? What can be represented? Now this also tells me something very, very interesting. What is number 3 in base 3? So 3 in base 3 is 10. 10 in base 10 is 10. B in base B is 10. 3 square 9. What is 9? That is 100. What will be B square? B square will be 100. 27 will be 1000. B cube will be 1000. And 10 cube is actually 1000. So it's the same number which is continuing. So 3 to the power n will be 1 followed by n zeros. B to the power n will be 1 followed by n zeros. And that actually helps me when I'm trying to convert numbers. Because I know that 1 represents 1, whichever base you're talking about. 10 represents 3. 100 represents 9. 1000 represents 27. 10,000 represents 81. How this helps me is, suppose I ask you what is the number, suppose I ask you what is the number 87 in base 10. So what 87 is effectively 8 into 10 plus 7 when I am dealing in base 10. But if I ask you what will this be in base 3, what are you going to do? You're going to break down 87 into this format. Because once you break down 87 into this format, your conversion to base 3 will be easier. 87 can be rewritten as 81 plus 6. 6 can be written as 3. So these are my values in decimal. See, do you know what is 87 in base 3? You don't. But do you know 81? Yes, you do. How much is 81? 1 followed by 4 zeros. How much is 3? 1 0. How much is 3 again? 1 0. So what will be my overall total? My overall total will be 1 0 0 2 0. So my answer will come out as 1 0 0 2 0. Are you guys okay with these values? You can ignore this. You can ignore this. I hope you guys are okay with these values. Tell me another one. Tell me another one that you would want to convert. Another one that you want to convert to base 3. Another number that you want to convert to base 3. How are you going to do that? $274. 274 is what you are trying to convert. So you have 81. So 274 is much bigger. So 81, 81, 81, that takes care of 243. 243. How much am I left after that? 274 minus 243 is 74 minus 43. So that is 74 minus 43 is 31 is left. 31 is left. So 31 can be written as 27 plus 4. 27 plus 4. And 4 can be written as 3 and 1. So then you add up all these values. So 81 is 10,000. 10,000. 10,000. I'm sorry, I got the zeros wrong. Then 27 is 1000, 3 is 10 and 1. Now when you add it up, you will see a new problem emerging. What is the new problem? So this will be 1 1 0 1. How much is this? 1 plus 1 plus 1. How much is this? 1 plus 1 plus 1. That is 3. But we do not have a 3 in this. We do not have a 3 in this. That means I cannot take 81. That means I cannot take 81. I have made a mistake here. I cannot do this. So if I cannot do this because I am getting a 3, what do I do? Any suggestions? What can I do? I look at even higher powers. Gautam is absolutely right. I need to look at 243, which is 1 lakh. Now I have 243, which is 1, 2, 3, 4, 5 zeros. Then I have 31. So 27, which is 1 followed by 3 zeros. 3, which is 1 0 and 1, which is 1, which gives me 1 1 0 1 0 1. And this will be my answer here. Are you guys okay with 1 0 1 0 1 1 in base 3 coming out as your answer? I'll show you a better idea, but I want you to understand what is happening here. I want you to understand, because only then I can explain a better method. If you understand this, then I can probably explain a better method to you. Are you guys okay with what I've done till here? Gautam is fine. Shashank is fine. Now, let me rub this off. Clarity. See, when we are converting from anything to base 3, what we are effectively doing, think about what we are effectively doing. We are effectively breaking it down into powers of 3. Effectively, what we are doing is we are breaking it down into powers of 3. See, we broke it down as 81, 243 and all of that. So what we have done is we have broken it down into powers of 3. We have broken it down into powers of 3, which there is another way to do this. There is another way to do this. If you attended yesterday's class on factorials, there was something that I discussed in that class. If you remember, suppose I asked you what is the number of zeros at the end of 124 factorial. The formula that was given to us was you divide 124 by 5, take its greatest integer function. Let me take it as 129. Then you divide 129 by 25. You take its greatest integer function. Then you divide 129 by 125 to take its greatest integer function, which will come out as 25 plus 5 plus 1, which will come out as 31, and 31 would have been your answer. So you had to make so many individual, you had to calculate 5, 5 square, 5 cube, and individually find them out and add them up. This was one method. The other method that we discussed yesterday, was that you can just repeatedly divide 129 by 5. 129 by 5 gives me 25. 25 divided by 5 gives me 5. 5 divided by 5 gives me 1. And 25 plus 5 plus 1, that itself gave me my answer. I did not bother about the remainders. But just by simply dividing, I got my answer. And the exact same logic and the exact same method can be used for questions on base conversions as well. Let me show you how to do that. So, suppose you have to convert 87 to base 3. You divide 87 by 3. How many times is it divisible? So 87 is divisible 29 times. Remainder is 0. You divide it by 3 again. Divisible 9 times. The remainder is 2. Divided by 3 again. You get 3. Remainder is 0. You divide it by 3 again. Divisible once and you get a 0. So now, what is the conversion of 87 to base 3? What you can do is, you can simply go from the bottom to the top. In the previous one, when you were finding out the number of zeros, you were just adding these values because that's what you needed to determine. Here, you cannot add them up. Because digits like 9 and 3, they don't even exist. In our base system. That is why we will look at the remainders here. So what is the conversion that I get? The conversion that I get is 10020 in base 3. Let's try another one. We calculated 274 here. So let's try that itself. So 274, you divide it by 3. 91 times it is divisible, 1 is a remainder. You divide it by 3. 30 times it is divisible, 1 is a remainder. Divided by 3. 10 times it is divisible, remainder is 0. Divided by 3. Thrice it is divisible, remainder is 1. Divided by 3. Once it is divisible, remainder is 0. So my overall answer for this is 101011 in base 3, which is what I had got here. You guys should be okay with both the methods. Because you don't know when which method will become useful, when which method will come in handy. Are you guys okay with this idea of conversions? Parth, Shashank, Gautam. Name of this, I don't know a name of this, man. I'm sorry. These are just couple of methods which I used for converting from base X to base Y. Now, if you notice in all of these questions, what I'm doing is I'm converting from base 10 to base 3. From base 10 to base 3. How will I do the reverse? Let me look for an empty space to do the reverse. Okay, maybe not in this slide. Let's see. Okay, so here I have a few empty slides. Okay, so till now what we were doing was we were discussing from base 10 to base 3. From base 10 to base 3. What about the reverse? Let me write down my base 3 once again. So 0, 1, 2, 10, 11, 12, 13 does not exist. 20, 21, 22, 100, 101, 102, 103, 103 does not exist. 200 and so on. What will be my decimal numbers corresponding to these? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and so on. Now if I ask you what is 101 in base 3 when converted to decimal, what you can do is, okay, 101, this is coming out as 10, so this will be 10 in decimal. It's very straightforward for me. But if the number is bigger, like the numbers we had here, what was the number that we had here? Where did it go? Empty slides can be problematic sometimes. Yeah. So the numbers that we had here were 10020. Let's take that itself. So if we have 10020, and that is something that we have in base 3 and we want to convert it to decimal. Once again, I will use the same idea. That I was using before. What is 1 in base 3? It is 1. What is 10? That corresponds to 3. 100 corresponds to 9. 1000 corresponds to 27. 10,000 corresponds to 81, so on and so forth. So if I have 10020, I can rewrite that as 10,000 plus 10 plus 10. So 10,000 I know is 81. 10 I know is 3. Another 10 I know is 3. And that will give me my overall value as 87. That's what I was looking for in base 10. Very similarly, what was the other one? The other one was 101011. Let's try that. One zero 1011. So that is effectively 10 1 followed by 5 zeros. 1 2 3 4 5. Then 1000. Then 10 and then 1. This is 243, 27, 3 and 1, which comes out as 4 carry over 1, and you get 274 as your overall answer in the decimal system. But once again, as you might have realized that this is a long and complicated method, once you have realized that this is a long and complicated method, what you are effectively doing here is whatever is the digits, whatever are the digits, they are essentially representing powers of 3. They are essentially representing powers of 3. So this represents 3 to the power 0. This represents 3 to the power 1. This represents 3 square, 3 cube, 3 to the power 4 and 3 to the power 5. As a matter of fact, you can look at it in the decimal perspective. If you look at it from a decimal perspective, what is the number 3458? That is 3 into 1000 plus 4 into 100 plus 5 into 10 plus 8 into 1. Now, very similarly, suppose you have 2, 3, 3, 4 in base 5. In base 5, you will write down 2, 3, 3, 4. The last digit is 5 to the power 0, then 5 to the power 1 into 5 square into 5 cube. If this is base 10, then these values would have been powers of 10. If this was base 8, then these values would have been powers of 8. And that's effectively how you can convert from base x to decimal. Are you guys okay with this conversion? Base x to decimal? Gautam, Parth, Shashank? So just to, kind of reconfirm, just to ensure that all of you have got it, confirming the ideas again. When you have something in base x and you need to convert it to decimal, suppose you have a, b, c, d and you want to convert it to decimal, that will be a x cube plus bx square plus cx plus d in decimal. That is the process. When you have a, b, c, d in decimal and you want to convert it to base x, you have a, b, c, d in decimal and you want to convert it to base x, what you are going to do is, you're going to take this a, b, c, d, you're going to divide it by x, you will get some result, you will get some remainders. Suppose you get the remainder as p, you will divide by x again, you get the remainder as q, you divide by x again, you get the remainder as r, you divide by x again, you get the remainder as s, you divide by x again, you get p as the remainder and u as the final result. Then your answer will be u, t, s, r, q, p in base x. Are you guys okay with these methods of conversion? If you are okay, assuming you are okay with these methods, that's broadly what majority of working in different bases is all about. So let's try this out. Convert this from decimal to binary. What's the answer you're going to get here? Convert this and tell me what's the answer you're going to get here. $452 from decimal to binary. What is the value? What is the answer that you're going to get here? You have 452 divided by 2, 226, remainder is 0. Divided by 2, 113, remainder is 0. Divided by 2, 6, remainder is 1. Divided by 2, 28, remainder is 0. Divided by 2, 14, remainder is 0. Divided by 2, remainder is quotient is 7, remainder is 0, divided by 2, you get 3, remainder is 1, you divide it by 2, 1, and the remainder is 1. Your answer will be starting from the bottom to the top, 1, 1, 1, 0, 0, 0, 1, 0, 0 is what you are going to get after converting this to binary. Try a few more. 8776 will be very time consuming. Please just try 145. 8776 will be very time consuming. Please just try 145. Tell me what you get here. The value for 145. You will have to repeatedly divide. Path says is 100, 1000, and 1. Let's check if path is correct or not. So 272 gives me 1. Now, some of the things which I have realized in case of binary conversions, which really help me is, if you see a number and it is divisible by 8, 72 I know is divisible by 8. So then what happens is, directly for that 8, you know that you will divide it by 2 thrice and all of them will get 0. So you can directly replace it with 3 zeros. You can just divide it by 8 instead of dividing it thrice. And this is a technique that you can use for making your calculations quicker. You divide it by 8, it's divisible thrice, you write down a 9 directly. And after 9, you again start your calculations by your regular method of 2. So you divide 2, 9 gives me 4. So that gives me 1. You got a 4. 4 once again is divisible by 4. 4 once again can be replaced with 100. 4 once again can be replaced with 100. So my answer here will be 100, then 1, 1000, 3 zeros, which is 8, and then again a 1, then again a 1, and this will be my conversion in binary. Makes your calculations faster and better. This makes your calculations faster and better. How about this? Haven't calculated that, Shashank. What I do know is that the number is divisible by 4. So last 2 digits will be 0, 0. That much I can tell you. How about this one? This is 9. See, again, it helps. See, with powers of 2, I can remember what the powers are. So this is 1, which will be 1. This will represent 8. I know that 1000 represents 8. So very quickly I can say my answer is 8 plus 1 or 9. How about these two? Please try making these calculations in your head. Gautam says that the first one is 6. What about the second one? First one is 6. What about the second one? Any values or suggestions for the second one? 73. Absolutely correct. See, again, powers of 2 I remember. This is 2 and this is 4. So this will be 4 plus 2 or 6. This is 1. 2 is not there. 4 is not there. 8 is there. 16, 32, 64 is there. So 64 plus 8 plus 1, that gives me 73. Even if so some of these calculations, should be easier for you in the head. Suppose it is 110 in base 5. You should be able to calculate this quickly. That will be 5. This will be 25. So 25 plus 5 is 30. What if this is 2120 in base 6? 2120 in base 6. How much will this be? Again, try and calculate this in your head. Try and calculate this in your head. That's what I want you to do. What does this 2 represent? 2 into 6. So this represents 12. This is 6 square. So this is 36. So now I've got 48. 6 cube is 216. Double of 216 is 432. 432 and 48. 432 and 48 comes out as 480. You should be comfortable with these sort of conversions. Bigger numbers, yes, it's a problem. Bigger numbers, yes, it's a problem. But these smaller numbers are something that you should be able to do in your head. Okay, let's try decimal to octal. What is the octal based system? In the octal based system is basically you're talking about base 8. The digits you have are 0, 1, 2 till 7. These are the digits that you have available. 0, 1, 2 till 7. Not something that you can do in your head because 8 cube, 8 to the power 4, keeping all of those in your head is difficult. So let's try and convert this. Base 8. How many times is it divisible? So 45, 40, so that is 5. 51, so that is 48, so 6. 35, so that is 4. Remainder is 3. 8 again. 70 times. Remainder is 4. 8 again. 8 times. Remainder is 6. 8 again. 1 and 0. 1, 0. 643 in base 8 comes out as my answer here. Are you okay with this value? (10643). Okay, Shashank also got this. How about 252? How about 252? How much will that be? Base 8. So 252 in base 8, 240 divisible thrice, 12 divisible once, remainder is 4 divided by 8, it's divisible thrice and the remainder is 7. So my answer comes out as 374 in base 8. 374 now. Utkarsh, please check your calculation. It's coming out as 374. Couple of other things which I don't know if you noticed here or not, that when you go from base x to base y and your value goes from a to b then they will have an opposite relationship. What I mean by that is, if a is greater than b, that will mean that x is lesser than y, and vice versa. So this is true not just one way but both ways. This is something which is true both ways, and if a is lesser than b, that will mean once again both ways that x is greater than y. When the base increases, the value falls. When the base decreases, the value increases. So octal to decimal, I don't think we need to do that once again. Hexadecimal is something that I will, want you guys to work on. Please convert this, because hexadecimal is something that a lot of students haven't really faced that often. So let me first tell you, see, till 8 it was very simple. Digits to be used were 0 to 7. But what are you going to do in case of a hexadecimal system? How are you going to find that out? How are you going to calculate it? Because you need, hexadecimal means 16 digits. So you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if I took 10, 11, 15, 10, 11, 12, 13, 14, 15. Suppose I took these values and the number which is given to you is 6, 1, 0, 5. Now the problem in this is going to be, is this a 3-digit number or a 4-digit number? Is this a 3-digit number or a 4-digit number? If I consider them as 4 separate digits, then my answer will be 6 into 16 to the power 4, 6 into 16 cube plus 1 into 16 square plus 0 into 16 plus 5 into 1. However, if I consider them as 6, 10 and 5, then it will be 6 into 16 square plus 10 into 16 plus 5 into 1. Obviously, these two answers are different. And that is what causes a problem. To avoid this problem, that whether to take 10 as 2-digit number or to consider this as 1-digit number, we don't have 10, 11, 12, 13, 14, 15. We don't have these numbers. And just so that this sort of confusion does not arise, to avoid this sort of confusion, we don't use 10, 11, 12 and stuff. Instead, we use after 9, we use A, B, C, D, E and F, where A is representative of 10, B is representative of 11, C is representative of 12, D is representative of 13, E is representative of 14, and F is representative of 15. Now, keeping all of that in mind, can you convert from decimal to hexadecimal? You're given the number 124. You need to convert it to hexadecimal. Keep all this, what we have discussed, in mind and tell me what your answer will be. Shashank says it will be 78 or 7B. I'm sorry, 7B. Let's check. You divide 124 by 16. How many times it is divisible? 16 into 6 is 96. Then another 16 is 96 plus 16 is 112. So 7 and my remainder is 12. So after conversion, I will get 7 and then 12 in hexadecimal. But this 12 does not exist, and this is precisely the confusion that I want to avoid. That is why I will use whatever is the representative of 12. The representative of 12 is C. So this will come out as 7C in hex. 7C in hex. Are you guys okay with this conversion? Let's try out the next one. Do we have something else? Okay. This is hexadecimal to decimal. Please try this out. Hexadecimal to decimal. Please try this out. What will you get here? Two, three, four. What will you get here? What's the answer? So here you will need to do 2 into 16 square plus 3 into 16 plus 4 into 16 to the power 0, which comes out as 16 square is 256, so that is 512, plus 3 into 16 is 48, so that is 560, plus 4 into 16 to the power 0 is just 4. This comes out as 564. A lot of you got that right. How about this? A102 in base 16. A102 in base 16. How will you find this one out? Same logic, same idea again. So it is A into 16 cube plus 1 into 16 square plus 0 into 16 to the power 1 plus 2 into 16 to the power 0. Now this is 2, this is 0, this is 16. That much I know. The problem is this A into 16 cube. A into 16 cube. How do I find that out? And that is the problem that I'm trying to solve. What does A mean? I go back to my original. A means 10. This will be 10 into 16 cube. How much is 16 cube? 16 into 16 is 256. 256 double 512. Double is 1024. Double is 2048. And final double makes it 4096. So it is 40960 plus 18. So my total is 40960 plus 18. That is 40960 plus 18 or 78. And this will be my answer. Did I make a calculation mistake? 256. Where? Yes. Oh, I'm sorry. It will not be 16. It is 16 square. That will be 256. And that will come out as 41218. Are you guys okay with this? So guys, that's essentially, the fundamental of base system. That's essentially the fundamental of base system about how you actually convert from one base to another. What are the bases that can be used? Why? I'm sure that a lot of us have seen these formulas and these ideas before. But in my opinion, the most important part of today's class was understanding why these things work. So what you need to understand is what was the logic, how we were converting from one base to another, why do we divide, why do we multiply. And if you got all of that, I'll be very happy that I have been able to actually teach something. In the next class, so this was the first class on base system. So base system, I'm dividing it into three classes. Base system, I'm dividing into three classes. The first class is what we just got done with. In the second class, I'm going to discuss, various conversions like binary to octal. How do you directly convert? Say from hexadecimal to binary and stuff like that. Oh, again, reminder, my new batch is starting from the 9th of June. You can use coupon code HANDA for the same. There is an offer which is going on. You'll get 1 month subscription free if you opt for the 6-month plan, and I recommend that you do that. Scholarship test Sunday at 12 o'clock. You can use coupon code HANDA for the same. The toppers get it for free. And this is the IP, MAT, BBA and the hotel management courses which are now live. Yeah. So I was saying what we'll be doing in the 12 o'clock class. We'll be adding, directly in basis, subtracting indirectly in basis. And if multiplication also, we will be covering all of this. We will be covering all of this in the second and the third classes. Third class, which is tomorrow morning at 12. sorry. So first class today, we just got done with it. In the second class, we will talk about direct conversions, addition, and other operations. In tomorrow's class, we will do some questions which have been asked in CAT and SAT before. So that's the agenda. That's the agenda for the classes as far as base system is concerned. I hope you guys like this. I request you to please like it on the app as well. Like it on the YouTube app as well. The more likes we get, the more views we will get. The more views we will get, the more free classes I will be allowed to take as a part of YouTube. That's pretty much it for today. If there are any specific questions that you want me to cover as a part of base system, I request you to please email them to me on ravihanda@gmail.com and I'll pick them up in tomorrow morning's class. That's it for today. That's it for now. I'll see you in another hour or so at 12 o'clock. Bye everyone. Bye Shashank. Bye Utkarsh. Bye Gautam. Hope to see you guys at 12.